Hey everyone, welcome back. So in this video we are going to deep dive into one of the most beautiful problem from the LeetCode is swim in the rising water. So the problem number 778 is very important because it gives you the idea of 2D array, and there are a lot of concepts behind this solving this problem. You can solve this problem by the Dijkstra algorithm and some other concept that we will discuss in this video. Okay, so let's talk about the question, or the question saying that. Okay, so as you can see this grid, right? So imagine you have given a n cross n grid. Okay, and each cell contains, or you can say each cell has a number, as you can see here. So these numbers represents the height or elevation, right? And you start at the top corner, okay, and you need to reach to the bottom corner. Okay, but there is a catch. The entire grid is underwater, okay, and the water level rises with the time. Okay, so let's suppose at time t the water level is t, and you can swim between the square, right, that are submerged at some water level, right? Meaning if the elevation is less than equal to t, it will be submerged, you can say, right? That we will discuss in the detail, but for now you understand this. Okay, so what is our goal? Our goal is we have to find the minimum time when we start swimming from the start and we want to reach to the end. So this is what we need to do. Okay, so if you observe this problem, right, we have given 0, 2, 1 and 3, right? So let's suppose at t equal to 0, okay, means when time is 0, when t is equal to 0, water covers any cell is 0. Okay, so when t is equal to 0, the water covers cell 0. Okay, so you are stuck here. Okay, so at time t equal to 1, right, water reaches cell 1, right? With respect to the time, the water level is increases. Let's suppose somewhere is that ground pump is there and water is increasing automatically, right? So very first this cell was completed when t equal to 0. When t equal to 1, this cell got filled, right? Means that with respect to the time, the water covers the cells. Okay, so let's suppose when t equal to 1, the water reaches cell 1 and you can move down, you can say, but still can't reach the end. Okay, so at t equal to 2, water covers 2, but the cell end cell is still too high, right? Because this is 1 and this is 3. Okay, so let's suppose when finally t equal to 3, everything is merged, right? Because 3 is here, and with respect to 3, if you compare, so we have talked about that the water, the squares will be submerged at a water level when the elevation is less than equal to t. So when t equal to 3 or less than equal to 3, everything is 0, 1, 2, right? This is 3. T equal to 0, t equal to 1, t equal to 2, t equal to 3. When t equal to 3, means the value that at each cell, if it is less than equal to 3, means if it is all submerged, right? So it's all submerged now, means everything is submerged, right? And we can swim from 0 to 3. So the answer is 3, right? And that is where we are getting the answer is 3. This is the minimum time which is required for path to exist from 0 to 3, from the start to end. Now think of it like that you are trying to find a path, right, where the highest elevation point you need to climb, right, and as low as possible, we can say that, right? Means we want to go from 0 to the highest L point, right? We can say. So this means among all the possible path from start to end, right? You have to try, correct? And you want the one where the maximum height along the path is minimum, correct? And that is our minimum path problem. So this type of problem is called minimum path problem. So this is nothing different than others, right? But this is the minimum path. So you know, we want to go to the, when we find the minimum path problem, right? We need to use the Dijkstra algorithm or any other best practice that we can do the BFS approach, right? We can do that, right? So the most intuitive way here is to solve this problem using the Dijkstra algorithm. But instead of minimizing the sum of weight with the minimum of the maximum height along the path, we will use the, let's suppose call the priority queue. We'll use the minimum heap where we'll store the each cell, right? So the current time or the cost, we can say, is equal to the max height, right? Which is encouraged, we will use here, right? And we'll keep adding into the priority queue. So we'll start from 0 0, and with the cost we'll say grid at 0 0. What is the cost? That will be the cost. Okay, then we always expand the cell with the smallest cost. Either we'll go to the smallest one in this side, or any other side. We can see the 4 direction we can go, right? So for each neighbor we have to calculate the new cost. New cost is the maximum between the current cost and the grid at the next row and column, we can say that, right? So that we have to check which one is the max. The first time we pop the destinations, right, and destination cell, and we'll say okay, cell go to the m-1 n-1, right, from the queue, and we'll go keep continuing that, we'll find the answer. So this is what we need to develop, right? Let's understand in detail. So let's understand, we have a grid, right, that we have given here. It was a 0, and then it was 2, and then we have is 1 and 3, right? So if we have given this grid, let's talk about the very first that we need to start is from where? At this cell, right? We have to start from here and we have to reach to this cell, right? So we'll say this is our start and this is our end, right? We can say means start at where? At 0 0, and end at is 1 and 1. Can we say that? So this elevation, we can say elevation is 0 and this elevation is 3, 0 1 2 and 3, right? So once you are at start, right, you can move, or any other cell, right, we can move what? We can move up, down, left and right. All the 4 directions we can move, right? But make sure you cannot move what? No diagonal. This is the prologue statement says, right? You can move all these 4 directions, but you cannot move to the diagonals, right? Remember the very simple things. Okay, now let's talk about some simple things. Okay, very first, this is what we have given, right? And if you want to see how water rising over times, right, so very first, when we are at here at 0 0, means we are talking about t equal to 0. So when t equal to 0, right, when t equal to 0, what will happen here? So when t equal to 0, water level is what? Water level is 0, right? So we will say, okay, the cells we can or you can enter is only whose less than equal to 0, right? It means if less than equal to 0 means only this will be submerged. Rest of the thing is not submerged. So the water will fill, or will say it will cover the cell 0, right? And other will not be submerged. Other there is no water. So this is submerged with the water. Understand? When we are talking about when t equal to 0, water level is 0. So we can only, we'll say, the water can only get filled, or you can say we can only enter into where the cell is less than equal to 0. You can only swim this cell. You cannot move to the another cell, right? And we'll say, okay, this is our start, this is our end, but the start is filled with this water. But still, other we have to check, okay? Others still have water or not, right? So we'll say only reachable is 0, 0. So we cannot move from here to any other place, because we need the water to rise, right, in the other cells. Okay, let's talk about when we move to the next. Okay, so very first it was 0, 0, 0, 2 and 1, 3. Okay, let's go to 0, 2, 1, 3. Okay, this is what we have given. So very first I told you that we have filled this water, right? So when we have filled this water, right, now we'll say t equal to 1. When t equal to 1, water level will be what? Water level is now is also 1. Can we say that? Because t move from 0 to 1. When t move equal to 1 means the water level will get updated from 0 to 1, right? Now any cell whose value is less than 1 is accessible, right? We'll say, okay, any cell whose cell with the value, you can say with the value, if it is less than equal to 1 is accessible, right? So let's find, there is only one cell, that is this, right? Less than equal to. Now the water filled to the this cell also, right? Now we'll say, okay, very first we saw that 0, 0 and 0 1, 0 is filled, right? So this cell has been filled. Now 2 and 3 is not filled, right? When we'll say t equal to 2, that time we'll say, okay, the cell was 0, 2, 1, 3. These two was already filled, right? Now t equal to 2 means the water level is what? Water level is 2, means we will fill all these values whose cell is less than equal to 2, right? Means this will be get filled, right? Means the cell with the value less than equal to 2 is accessible, and we'll say this will filled. Similarly, when we'll move to t equal to 3, right, the water level is 3. So we'll say the cell value is less than equal to 3 is accessible. So we'll say, okay, all is accessible now. That is why we have seen that the answer was coming is what? 3. Because now we'll say from 0, 0 means it is the starting point and this is the ending point. Anybody can swim here and he can reach to here, but he cannot come directly like this. Okay, he can come by this way or this way or like this. Okay, and he can reach to here, right? This is what we need to do, right? It means now 0, 0, 1, 0, 0, 1 and 1, 1, all the cells are filled. Now the path exists is what? We'll say 0, 0 to 1, 0 to 1, 1. We can say that. Or another path is possible is what? 0, 0, 0, 1 and 1, 1. No diagonal. Okay. Now you can swim from start to end here by these two way, either this way or either this way. Okay, and that is why we are getting the answer is 3. I hope you understands. Now let's talk about how we are going to implement it. Okay, so we'll use Dijkstra, okay, Dijkstra approach, you can say. Okay, using the Dijkstra algorithm, we can use this approach and we can implement. So let's imagine that you has a heap map, right? So we'll say, okay, we has a heap map, right? So this heap map will start adding what? The lowest tile, and we'll keep adding on the max one, right? Because we need the minimum heap, right? So we'll take mean heap is not the, you can say mean heap, you can say that. Okay, so mean heap will work like a thing, like you can add like a priority queue, right? This is a priority queue where internally use the mean heap. So very first in the priority queue, we'll pick what? We'll pick the 0 0 cell, and the height here, and the first height is nothing but what? H equal to 0. Height is 0. Then we will add here 1 0, where height is 1, and 0 1 height is 2, right? Then we'll say, okay, pick 1 0, and next the lowest, and similarly we'll keep adding. We'll add, okay, add now 1 1, height is 3. Now we reached to the height is equal to 3 already, right? So we have reached here. Like that we will fill here, and we'll keep checking the conditions. Now let's talk about what I'm talking about. Let's suppose we have the priority queue, and we will use the etc, right? So very first what we will do, we'll push the idea is to we'll push the start, right, with cost. So cost is nothing but its height, right? Its height initially is 0. So when we expanding a cell with the current path, right, current path cost, right, let's call the current cost, right, we'll keep pushing the neighbor that is using the new cost, right? So we'll say, okay, this is our new cost, and the pushing our neighbor cost is, let's call the new cost, right? So we know the current cost, this is our new cost. So to find the new cost, you need to do what? The max of the current cost, and we'll use the height of, you can say, height of the neighbor. Okay, this is what we need to do. So when we do the priority queue, so the priority queue always expand the cell with the smallest path cost first, right? And the first time we'll pop, let's call the E, the pop cost is the answer, right? So we'll keep doing that, and we'll find the answer. Okay, how? Let's understand. So very first, the initial grid, we know that this is our 0 0, and its cost is 0. Then we have 0 1, and we'll say height is 2. Similarly we'll say 0 2, and we'll say height is 1. Similarly we'll say 1 0 is 3, 1 1 is 5, 1 2 is 2, and 2 0 is 4, and 2 1 is 6, and 2 2 is 3. So in the starting, what we are doing, we are pushing 0 0 with cost equal to grid at 0 0, which is 0. So initially what we need to do on the priority queue, we'll say, okay, you add this 0 0 with the 0, means I'm talking about we have the priority queue, and on the priority queue we'll store initially is 0 with the 0 0, like this. So this is the first entry when we are talking about 0 0 equal to 0, means we have added the very first initial steps. Once we added here PQ, right, we'll say, okay, what is in the visited? We'll check in the visited, right? So we'll check initially visited is null, right? So we'll say, okay, now pop the 0 0, we can say. So we'll say pop 0 0, and what is the cost? We know that cost is 0, right? So with the cost is 0, now we'll say, okay, now mark visited. So we'll mark this visited. The 0 0 is visited now. What is the neighbor? We'll say, okay, neighbors of this 0 0 cell is what? Very first is 0 1, and its height is 2. So we'll find the new cost, and the new cost we can get is max between 0 to is 2. So we'll say, okay, means push 2 0 1, like this. We'll keep adding there, right? Similarly, the other neighbor is 1 0, right? Similarly, what is the height here? Height equal to 3. So we'll say, okay, when we are going to push 1 0 and height equal to 3, what is the new cost? We'll find the new cost. New cost is, we can get the max of it is 0 and 3, will get 3. It means we need to push what? 3 1 0. Understand? Like this, we'll keep doing the adding and pushing. Understand? So let's suppose if we have pushed everything here, so what is in the priority queue? The priority queue will say, okay, the currently we have on the priority queue is 2 0 1, let's call it, and another is 3 1 0. Okay, let's suppose for now we have these two, and as you can see, this is ordered by cost, right? First is 2, then 3. So minimum cost is first, then it is coming the max cost, right? So we'll say minimum cost is 2, then 3. Let's say now we'll say what is in the visited we have is 0 0. Okay, so when we go to the step 2, what you need to do, we know that the priority queue contains what? So we'll pop the smallest one. So what is the smallest one? 0 1, right? 2 0 1. So we'll say pop the smallest one, and the smallest one we have is 2 0 and 1, that we have seen, right? That we have seen here is this is the smallest one, right, on the priority queue. So we'll pop this one. We'll say what is the cost here? So cost is 2. So we'll mark this as a visited, mark visited. Okay, so we'll mark visited is 0 1. This is visited. Now we'll say, okay, what is the neighbor of 0 1, right? So we'll say, okay, first we have is 0 0, which is visited. So we'll skip, we'll not do anything. Okay, then we'll say we have is 0 2, whose height is 1. So we'll say, okay, it means new cost we have to find it. We'll say max between 2 and 1 is nothing but 2. What you need to do, push this. So we'll say, okay, push 2 0 2. So we'll push this one. Next neighbor is 1 1. So when we have known 1 1, what is the height here? Height is 5. If you go here, I have already written. So you can say, okay, 1 1. Height is what? Is 5. So we can say, okay, height is 5. Okay, you need to find the new cost. So when we going to add 1 1, height is 5, height is 5, and the new cost we have to find. So new cost is max between 2 and 5, right? Previous is 2. Okay. Then here we'll find is 5. It means we need to push 5 1 1. Correct? Now the priority queue contains is 202. Then we have 310, and now it came 511. Okay. So this is our priority queue. We have already marked visited is 00 and 01. Similarly, you will pick this smallest one. You will remove from the priority queue. You will mark in the visited set. You will add in the visited set. Like that you will do, and you will keep moving ahead. Okay, until let's suppose in the last you will get what? 3 2 2, where the cost will be 3, and this is, you can say, row is 2 and column is 2, and this is nothing but end of cell E, means we are at the end. So we'll say, okay, since we pop the end, right, end cell, now algorithm should return our answer 3. So this is what we need to develop. Okay, let's understand the code, how we will implement it. So as you can see here, what you need to do, you first you have given is grid, right? You will find the grid, then you will say if n equal to 1, means if there is only one cell, will return this value. Okay, otherwise you create the visited cell, and you need to find the priority queue, right? So you know the minimum priority queue, how you are finding that. Okay, then the priority queue will add the very first cell, and these are the 4 directions that we have talked about. Okay, it is very simple code. You just need to check the priority key is not embedded, because just we have added is the very first cell. You will get the very first cell, that is the current cell, and you will find all its the neighbor nodes, right? So you will find the T, you will find row, and the column you will find. You will check all the possibility. Is it the last one? If it is, you are the last, you return. And when you will check the row should be, row is n-1 and column is n-1, means you are at the last, right? n-1, right? Then you will return the answer. Otherwise you will find, if it is visited, you will continue, you will not recalculate again. Then you will mark the current cell. If it is not the visited, you mark it as a visited. Then you will go for all the 4 directions, right? The neighbor nodes, where you will find the next row and the next column you will find like this, and you will check all the boundary condition. It should not be visited. You will add on to the priority queue, right? You will find the max that we were finding, that you will take the max of the current one, the previous one, and the current value. Okay, you will find the max, and then this is your row and column. Whatever the max is there, you will keep offering on the priority queue, means you are adding on the priority queue. And in this way, once you will reach at the last, you will return the answer. Otherwise you will return -1. This is what we have, guys. If you like this video, please hit the subscribe button if you are at the new at Excel Funda. Otherwise like the video and share with your friends, your colleagues who is preparing for the FANG interviews. In case you want the structured way of preparation, you can contact me. Thank you for watching this video.